Hello, good day. Yes, in this virtual class, we'll be looking at this question and how it can be resolved. Now, let's assume that this is logarithm, this is logarithm, this one is not logarithm, so how do you evaluate this? Okay, now for here, it would have been very easy for us to tackle if we have known that the base of the two logarithms are the same, but in this case, they are quite different. So we cannot apply the law of logarithm here. That has to do with when it is subtraction you divide. Okay, for here, this one is completely a different ball game. So this is we can only apply the law of indices here. So, but let's see what can be done in a situation like this. Since the bases are different, you can apply the change of base become an essential tools for resolving this. So, what does this change of base specify? I said that for instance, if we have a logarithm of this, by looking at change of base, we have a log, let's say y of base x, and we are changing it to another base, let's say base p. So this will become log y to base p. Then this base here become log, divide it using division. This is x to base what? P. So we use the same thing on these two logarithms. So let's see how this can be applied. This becomes log 9 over 16. Let's say we're taking it to base 10. Divide log 81 by 256 to base 10 minus log the cube root of a to base 10 divide log, the base here become the log here, that's square root of a to base 10. Here it has nothing to do with logarithm. We just have to change this to improper fraction. So if we do this, 1 to 1 multiply 1 is 1 to 1, added to 23, that will give a 144 over 1 to 1 raised to power negative half. Now, if you take a very good look, at 9 over 16 and 81 over 256, they have some peculiarities. That is, 9 over 16 can also be expressed as 3 over 4 raised to power 2. Then 81 over 256 can also be written as 3 over 4. This one raised to power 4. Why this also raised to power 4? That means 3 raised to power 4 is 81. 4 raised to power 4 is 256. It's like we're saying, okay, 64 times 4. This is 6. This time this is 24 plus 1. That gives 25. That makes it 256. So this number here can be expressed as this. Why this can be expressed as this? So what we need to do similarly, if you look at root, this one is root. Cube root of a can also be written as a raised to the power of 1 over 3. Then this one, the square root of a, can also be written as a raised to the power half. So we're trying to do some simplification here. Okay, so if we come here, we can also rewrite this, that this one is log 3 over 4 square divide log 3 over 4 raised to the power of 4 minus, here will become log a raised to power 1 over 3 divide log, all this one are to be same, but even though if we don't indicate it, it doesn't necessarily matter. So this become a raised to power half plus. Now we record that in indices, once you have something like this, we have a e raised power minus n is equals to e raised power is equals to 1. Divide a raised power n. So we apply this to this part so that this become 1 divide, okay, we have to, in situation like this now, it become 144 over 121. So raised to the power of what? Half. Raised to the power of half. So we have removed the negative. Okay, with what we just said here, we said that if we have a raised power negative n is equals to 1 divide a raised power n. So we have applied this here. So let us now move on. If you look at this from law of logarithm, if you have log s raised power n is n, this index here will come behind, will act as a product to multiply the log. So we'll do the same thing here. This is n log, become n log x. So we use the same approach here to apply to this. This become 2 log 3 over 4 to the 10. Divide here, bring this 4 behind, 4 log 3 over 4 to the 10. Similarly, 1/3 here will also come behind, minus 1/3 log a, divide half log a. So if you come to this here, this is plus, this is 1, we change this one become times. So by the time you change it to times here, this denominator become numerator, this become 121 over 144 raised to power half. So if you look at this place, you can easily now simplify. So this logarithm, they are the same, so you go out. So if you look at this become 2 over 4 plus, look at this here. What we have here is 1 minus, okay, let's say minus, this one is minus 1 over 3 divide 1 over 2. Here, this one means 121 means 11 square. Okay, so this one we can also say this one is 11 over 12 raised to power 2 times the half, times this half here, or simply you just find the square root of 121. That's the meaning that if you have a raised to power half means square root of whatever you have there, square root of a. So the square root of 121 and this here, we can see simplify this become 1 over 2 minus 1 over 3 times, we change this to multiplication and this become 2 over 1 plus 11 over 12 here. So if you look at this become 1 over 2, bring this one plus 11 over 12, here become minus 2 over 3. So let's look at the LCM here. The LCM is simply just 12. So we can come here and put the LCM as 12. Now 12 divide 2 is 6. 6 times 1, we have 6 here. Then here 12 divide 12 is 1. 1 times 11, have a plus 11. Then 12 divide 3 is 4. 4 times 2, that gives us 8. So I have a negative sign here, so that is minus 8. 6 plus 11 is 17. 17 minus 8. Okay, so that gives 9 over 12. So if we simplify, if you look at 9 over 12, it's the same thing as 3 times 3 here. Here is 3 multiply 4. And eventually the result becomes 3/4. So this is how to handle these questions. The first thing to do is just knowing that the bases are not the same, you can use the change of base, which is very powerful and useful tool for reducing this number to this form, and from there you carry out the procedure. Please, if you find this video very useful, let me subscribe, like, share. Also follow my page for more of this useful information. See you in my next class.